It's amazing, isn't it, how easily we categorize things as humans?
Yeah.
Like colors, cities, music genres. It feels so natural.
Uh-huh.
But when it comes to machines, well, it's not quite as straightforward.
You're right. They need a little more guidance when it comes to categories.
It turns out those categories, the ones we use without even thinking, they can be a real challenge in machine learning.
Oh, absolutely. A big challenge. It comes down to the fact that machines, they really rely on numbers, on data that can be measured.
Okay, yeah, that makes sense.
But so much of the information we deal with, it's categorized in ways that don't easily translate into numerical values.
So how do we bridge that gap then? Can't we just, I don't know, just plug those categories directly into the model and let it sort things out?
Well, if only it were that simple. Imagine, for instance, a model trying to learn, let's say, about house prices in different cities.
Right. Okay.
And if we just feed in New York or San Francisco as those raw categories, the model might mistakenly assume that one city is inherently, well, greater than the other.
Oh, I see what you mean. Like, it might think one is better or worth more just because of the label, not because of any real factors.
Exactly. And that's where the whole concept of encoding comes into play.
Encoding.
Yeah, it's essentially like giving the machine a translator, a way to understand these categorical concepts, but in a numerical language that it can work with.
Okay, that sounds pretty crucial then. Encoding. So how do we actually go about, translating for the machines? What are some of the ways we can do that?
Well, there are a few different approaches, each with its own strengths and weaknesses, depending on the situation.
Uh-huh.
One of the simplest methods is called label encoding.
Okay.
It's basically assigning a unique number to each category. Like, let's say we have colors. 0 for red, 1 for green, 2 for blue.
Right. A simple numerical representation.
Exactly. Now, this works well when there's a clear order to the categories, a natural ranking. Think of something like education levels. High school, then bachelor's degree, then master's. There's a progression, so the numbers make sense in that order.
Makes sense. So it works for things like rankings or levels. But what about cases where there's no inherent order, like with the color example, blue isn't better than red?
You got it. That's where label encoding can be a bit misleading.
I see. Yeah.
Because if we apply it to nominal categories, those where the order doesn't matter, it might lead the model astray.
Yeah, because it could think blue is greater than red just because it has a higher number, even though that's not actually true.
Right, exactly.
Gotcha. So it's all about choosing the right encoding method for the type of category you're dealing with.
Absolutely.
What other options are out there, especially for those categories where order doesn't matter?
Well, one very popular method is called one-hot encoding. And instead of assigning a single number, we actually create a separate binary column, a yes-no column, for each category.
Okay, so instead of one column with numbers, we have multiple columns with just zeros and ones.
That's it. So if we go back to our color example, we'd have a red column, a green column, and a blue column. And if an item is red, we put a 1 in the red column and 0 in the others.
Oh, I see. So it's like a checkmark system, indicating which category applies.
Precisely. And this avoids any implied ranking or order that could confuse the model.
So each category gets its own spotlight, so to speak. No need to compare them on a single scale.
Exactly.
This is really fascinating stuff. It's like we're creating a whole new language for machines to understand these categories.
You could say that, yeah. We're bridging the gap between human thinking and machine processing.
Are there any other encoding methods we should be aware of?
There are. Another one is called ordinal encoding.
Okay. Ordinal encoding.
This one's ideal for when you have categories with a definite order, but you don't necessarily want to assume equal intervals between them.
I see. What would be an example of that?
Think about customer ratings, like low, medium, and high. We could encode those as 0, 1, and 2.
Right, representing the order.
But we're not implying that the gap between low and medium is the same as the gap between medium and high.
That makes a lot of sense. So we have options for ordered categories and options for unordered categories. But I imagine there's still some challenges in figuring out the best approach, right?
Oh, there always are. Sometimes we might be dealing with a situation where we have a massive number of categories, like, for instance, thousands of different cities.
Whoa, wow. Yeah, that would be a lot to handle.
Right. And if we use one hot encoding, we'd end up with, well, thousands of new columns.
Oh, that would make things pretty complex, wouldn't it?
Yeah, it could make the model really complex, potentially slow it down. So in cases like that, we might consider other techniques like target encoding, where we actually use the target variable, what we're trying to predict, to represent the categories numerically.
Okay, so using the target variable as part of the encoding. That sounds interesting, but I have a feeling there's a trade-off there
You're
somewhere.
sharp. There is. The potential issue is overfitting. The model could become too tailored to the training data and might not generalize well to new data.
Right, like it's memorizing the answers instead of learning the underlying concepts.
Exactly. So it's a powerful technique, but we have to be mindful of that risk.
So it's all about finding the right balance, the right encoding method for the data and the problem you're trying to solve.
Absolutely. And that's what makes this field so interesting. There's always this element of exploration and fine-tuning.
This is really eye-opening. I'm starting to see how encoding is this key that unlocks the world of categorical data for machines. It allows them to process information that would otherwise be meaningless to them.
It really is. It's the bridge between our human way of understanding the world and the way machines process information. And as we delve deeper into the world of machine learning, we'll see just how crucial this concept of encoding truly is.
I'm ready to dive in. I feel like we've only just begun to explore the whole world of encoding.
Right.
What are some of the real-world challenges people might face when working with these categorical data?
Oh, for sure. There are a bunch. One that comes up a lot is when you have features, those data points, that have tons of unique categories, like a city column with thousands of different cities.
Oh, wow, yeah. That sounds like a lot to manage.
It is. It's called high cardinality.
Yeah.
And if you tried to use one hot encoding there, well, you'd end up with thousands of new columns. It'd be a mess.
Yeah, I could see how that would get out of hand. What do you do in those situations?
There are a few strategies. You might consider target encoding, remember, where we use the thing we're trying to predict to help represent those categories?
Right, using the target variable itself.
Exactly.
Yeah.
Or there's frequency encoding, where you basically replace each category with how often it shows up in the data set.
Okay, so you're kind of compressing the information in a way that still makes sense to the model.
Exactly. It's all about finding clever ways to represent those categories without creating this huge, unwieldy data set.
Makes sense. Now, you mentioned overfitting earlier. Is that something that pops up a lot when working with categorical data?
Oh, yeah, definitely. Especially with methods like target encoding. Got to be careful there.
Overfitting, it's like when you cram for a test, right? You memorize the answers, but you don't really understand the material.
That's a perfect analogy. And in machine learning, it means the model gets really good at predicting the data it's already seen, but then it fails when it encounters new data.
So it doesn't generalize well.
Right. Doesn't generalize well at all. It's too specific to the data it learned from.
So how do you prevent that? How do you make sure your models are actually learning and not just memorizing?
Well, one technique is called cross-validation. It's basically like giving the model multiple practice tests with different questions each time. That way, you can see how well it performs on data it hasn't seen before.
Oh, that's smart. So it's like testing its true understanding, not just its ability to regurgitate.
Exactly. And that helps prevent overfitting. Now, another thing to think about is interpretability, especially when you're using methods like one-hot encoding with all those extra columns.
Right. I could see how that might make things harder to understand.
It can, because it becomes harder to see how the model is actually arriving at its predictions, like which features are the most important, what's driving the decisions.
So it's like the model becomes this black box, and you can't really see what's going on inside.
Kind of, yeah. And that can be a problem, especially if you need to explain why the model is making certain predictions.
So what can you do about that? How can you
Yeah.
make these models more transparent?
Well, there are techniques like feature importance analysis that can help you peek inside the black box, so to speak. They tell you which features are having the biggest impact on the model's predictions.
Oh, that's helpful. So you can kind of see what the model is focusing on.
Exactly. It gives you more insight into the model's decision-making process.
This is all so fascinating. I'm realizing that encoding isn't just some technical step. It really is this fundamental part of making machine learning work in the real world.
Absolutely. It's how we bridge that gap between how we humans see the world and how machines process information. And as we continue exploring machine learning, you'll see how encoding pops up again and again.
I'm ready to keep exploring.
Yeah.
It's amazing how much there is to learn about this.
Oh, me too. This is just the tip of the iceberg, really. But it's a crucial part, and understanding it will give you a much deeper understanding of how these models work.
I'm excited to see where this journey takes us next.
Yeah.
So we've talked a lot about the technical side of encoding, different methods, the challenges. But I'm wondering about the bigger picture. Like, why does encoding even matter to the average person? What are the real world implications of all this?
It's a really good question. Because at first glance, encoding might seem like this kind of obscure technical thing. But it actually has these huge implications for how we understand and use data in our world, especially as, things become more digital.
Right, but everything's data now, right?
It really is. Think about it. Your online shopping, your social media, your health records. It's all being captured, categorized, analyzed.
And a lot of that data isn't just numbers, right? It's about our preferences, our demographics, even things like diagnoses.
Exactly. So much of it is categorical. And that's where encoding comes in, because it allows machines to actually make sense of all this data, to extract insights, to make predictions that can really shape our experiences.
So it's not just about making models more accurate. It's about helping machines understand the world in a way that's closer to how we do it.
Exactly. It's about bridging that gap between human understanding and machine processing. And as these technologies get more and more advanced, the ethical considerations become really crucial.
Oh, absolutely. Ethics in AI, that's a huge topic.
It is. We have to make sure that these models are fair, unbiased, and transparent in how they make decisions. And encoding actually plays a big role in that because it can influence how biases are either amplified or reduced in the data.
So it's not enough to just build models that work. We need to build models that work fairly.
100%. And that requires us to really understand the data, the encoding methods we're using, and the potential impact on different groups of people. It's a responsibility for everyone involved, from the data scientists to the policymakers to the everyday people who use these technologies.
So understanding encoding, it kind of gives us a peek behind the curtain, right? It helps us understand how these systems are working and ask the right questions.
It does. It makes us more informed, and it helps us hold these technologies accountable.
This has been an incredible journey. We've gone from the nitty-gritty of encoding techniques to these really big picture implications.
It's been a pleasure to explore it all with you.
And as we wrap up, I'm feeling a real sense of, I don't know, possibility. Like there's so much potential here, but also a need to be really thoughtful about how we use these tools.
I agree. The world of data is constantly evolving, and we're just starting to understand the power and the responsibility that comes with it.
So to our listeners, I think the takeaway is to stay curious, keep asking questions, and keep learning. The more we understand about these technologies, the better equipped we'll be to shape their future.
Couldn't have said it better myself. It's all about understanding and engagement.
And on that note, we'll wrap up our deep dive into the fascinating world of encoding. Thanks for joining us on this journey. It's been a pleasure.
Until next time, keep exploring.